Hi, I'm Muralidhar and my teammates are Sudarshan, Manjunath and Manoj. We are doing a project on voice controlled wheelchair for physically disabled people.
So he is giving the words command, and as per the command the wheel is moving forward, reverse and left, right.
Good morning everyone. My name is Madhusudan and my teammates are Hamish, Harshita and Mridula, and our project is data transmission using Li-Fi. And our main project is to provide the data communication using the visible light spectrum, which is shown here. We can transmit both text and image using the LED. Will be the transmitter part and the solar panel will be the receiver part. So here we can transmit the text as shown now. Now the text is transmitting and the receiver we can see the text at the receiver end. So this is our project. At the same time we can send the image also using same technology.
I am Vinayak from ECE A section. My teammates are Akash, Chirag and Abhishek. Our project title is Design and Analysis of 3-bit Flash ADC up to sampling rate of 1 GSPS. The main reason to choose this project was to design a Flash ADC architecture which converts the analog signals into the digital discrete signals. This is the Flash ADC architecture block diagram we have designed, and this is the design part that we have made in the Cadence Virtuoso 180 nanometer length channel length. The problem statement of our project is that it's limited resolution, high power consumption and accuracy limitations. That means we have used 3-bit Flash ADC architecture by making use of TIQ comparators, that is 2n-1 comparators, and the main reason to choose this was the objective, that is which consumes more power. To reduce that one, we have worked on this with the comparing the each and every comparators. That's all about our project.
I'm Bhavna and these are my teammates Chandana and Arundhati. So we have done a project called leaf disease detection using image processing. So our project is basically to detect the leaf diseases. We have chosen grape leaf and we have chosen the 3 diseases called leaf blight, esca and black rot. So our project basically detects these 3 diseases, and that's it. So we have chosen a Telegram application through which you can send the leaf image. So we'll be interconnecting these things with the Telegram application. So first you have to choose a language using Telegram. So 1 for English and 1 for Kannada, 2 Hindi and 3 for English. So I'll choose 1. So along with my name it has appeared like you have chosen Kannada language. So you need to wait for 1 to 2 minutes so that 3000 images will be processed. Okay, it will ask for the grape leaf image. So we have sent an image and it will say like the image is received and the disease found is esca. So that's it.
My name is Srijit Vinayar. My teammates are Rahul and Parvati. This project is automatic English to Braille translator. Here we will be capturing image from the camera, where the image or the text will be kept here. After capturing, it is processed and the English is converted to Braille. The major reason, the problem statement of this project would be like the scarcity of visual scripts for reading for deaf and blind people, as they can't read normal books. They need Braille books, but the Braille books are costlier and also non-accessible. Here the main objective is to provide a device which can convert English to Braille, and we are using Tesseract algorithm for. After dumping this code to the Raspberry Pi, if I press this button, which is used to operate the camera will click the image, and then it will start converting the image. Now after converting, the letters which are in the script will be displayed using the vibrator motor. A user can keep his palm on the device and can sense the vibration and determine which letter is. You can see these are the scripts which are determining. For A it will be only one vibrator on, and for different combination there are different letters. Thank you.
I'm Spurti. My teammates are Vinith Reddy, Tejas M, Vinith KS. Our topic is implementation of aeroponic system. Objective of our project is to provide an optimal growing environment that maximizes nutrient uptake and promote healthy growth.
My name is Tej Kiran. This is our project drone with robotic arm. My teammates are Swastik JK, Shreya Rai, Vachanashri. Main objective of our project is to deliver medicines during flood time. Our drone will be able to lift 2 kgs of payload and deliver it to the desired location. This is the arm. This will move inside and outside. It will lift the payload. The drone has capacity of 6 kg to lift 6 kgs. This is a hexacopter. We have used NRF module for wireless controlling of the servo motor. Servo motor used is MG995 servo motor, which rotates 360 degree. This is the hexacopter we are using. It can lift up to 6 kgs. It will be controlled using a FlySky wireless controller.
So good morning, myself Yashas. So my teammates are Sudarshan and Subramanya. Our topic is medical image fusion. So what it will do in this project is, you can see here there is a CT image and MRI image. So by using a technique called DWT, what we will do is we will fuse the both images, and in a single image we will get the properties of both CT and MRI image, which will help the doctors to analyze and diagnose the diseases very nicely, and time consuming will be less. Thank you.
Good morning, I am Advesh, and my project is smart irrigation system using web server, and here you can see the video of the smart irrigation system. This is how it pump ons, and the valve changes. And the third lane will be switched on. Like after, you can change the lanes also here. And this is the web port where you can interface, you can turn on the pump, and you can change the lanes, all those things you can do it here. Thank you.
Warm gestures. I am Nidhi Somaya CK. These are my teammates Pallavi and Sinchana. Our project is Smart Agriculture Monitoring and Controlling System. Problem statement is ineffective and unscientific water management results in insufficient or excessive watering. Lack of mechanisms to store data and notify the farmers about intrusion. And this is the methodology implementation, and these are the results obtained in this. Okay, in a farmland there are two types of land gestures. One is dry land, another is wet land. In dry land, if you are taking in the soil moisture thing, initially when it is detected whether the moisture is below 50% or not, it will send a note to the motor, and the motor will get turned on. When the value is below 50%, here we have taken the threshold as 50%. When it is before 50%, it will send a note to the motor, and automatically motor will turn on, and you can see here water is getting detected. I mean, it is getting poured out through the drip irrigation here. When it is in wet condition, it will send a notice to the module telling that water is detected and moisture is like above 72, means above 50% it is, and 72%, and it will send a note to the motor. Again, the water is, it will get stopped. And this is intrusion mechanism. In intrusion, while we are far from the farmland, we can't assess whether what are the which and all animals have been getting in. So here when intrusion is happening, you can see like I have intruded here, and the values are showing here, and the default value is 1198, and it will send a note to your telegram bot that alert motion has been detected. Thank you.
Hello, my name is Jafar, and my teammates are Anvit, Sai Kumar and Manu. We have done a project on defect detection in PCB. Here we identify the defects that are present during the after the manufacture of the PCB. This is our problem statement, and in our project we are taking a reference image and a test image. Test image is such that it is having defects. So we have written a MATLAB code to identify those defects, and the defects will be identified and located in the MATLAB. See, as you can see here, these white dots, these are the defects present in the test image. When you locate it here, it will show some coordinates. You just have to locate the coordinates in the test image. This is the defect. Open circuit defects.
Hello, my name is Anjana, and this is our project, multi-purpose Avalanche robot, and my teammates are Deepa, Abhiksha and Lalita. And the main objective of this project is to provide surveillance on the wheels. The camera is mounted on the wheels and it provides surveillance while in the movement, and it also detects for the human appearance and sends a message to the user who operates it. And this is the way we operate it. This is the live video streaming, and this is the message we get when the human is detected. Thank you.
Good afternoon, my name is Sai Nayak, and my teammates are Amulya Manjunath, Arsavardhan Sanath Gattige and Bhavani Karegodar. So our title of our project is Single and Double Precision Floating Point Multiplier under the guidance of Dr. Madhusudanake. So the main objective of our project is that to reduce the power consumption, area and number of gates consumed by the design. So the single precision and double precision multiplier, which is also used for the performing the complex calculation, so that we are just implemented that project by using cadence tool. So first we just simulated the code in SimVision tool. So this is SimVision tool. We have just simulated that our design code in the SimVision tool. And after simulating the design code, we will come to know that it is properly working. Means while providing the input, it will generate the output. After that, we will go for synthesis. This is the step which is been involved during the synthesis process. The input for synthesis is that like standard cell libraries, Liberty file, etc. And this is the floor planning of single precision. This comes under the back end of the VLSI design. So floor planning is mainly done because where to place the ports, where to place the design, where to place the netlist. So that kind of planning which is been done in floor planning. And after that, this is placement. So after floor planning, wherever we have planned to place the design, we will place the design. Mainly it consists of flip-flop, latches and mux gates, etc. And after that, we by just comparing the existing paper and proposed paper means means depending upon a project, we have just reduced the number of gates. So we have achieved number of gates. We have reduced the some terms of gate, amount of gate, and after that, this is the double precision floating point multiplier simulation code simulator. And after that, this is also the floor planning which is be done for the double precision where to place the design. And after that, this is the placement of our design. So where to place the ports, net list, and all the kinds of standard cells. And after that, we have concluded that we have reduced the amount of power and number of gates and number of areas. So this is the 3 parameters we have reduced in our project. So we have successfully completed our project by reducing these kind of 3 parameters. And this is the conclusion. Conclusion is that we have just reduced the power, gate, and amount of power gates, etc. So this is our project. Thank you.
Hi, I'm Nikhil, and here is my teammate Nitish Shedan and Sathik HP. And this is our project Smart Ration Distribution System. In this project, we have used Arduino Uno, X keypad, and LCD display, and relay board, and stepper motor driver, and solenoid valve and flow sensor. So initially we store all the user information will be stored in this website. We can enter the name, RFID number, mobile number, rice, and oil. It will be stored in database number. Whenever the user scans his RFID scanner to the RFID card to the scanner, he will get the notification like enter the password, because we stored all the information in this database. So if the database and the card is matched, all the authentication service will be retrieved by the Arduino Uno. So after the scanning, he need to enter his password into his hex keypad. Like we are already given the password to the RFID card, like 1111. It's a default password. So after pressing the 1111 in this hex keypad, he has to like the user has 2 choices. Like if you want to retrieve the rice, he need to press 1 in this hex keypad. After pressing the 1, the stepper motor driver will be open and the rice will be poured into the dispenser. Like this way, the stepper motor will work. And for oil, you need to press 0 in the hex keypad. After pressing 0, the solenoid valve will be open and the flow sensor will be calculate how much oil is dispensing through the solenoid valve. After reaching the maximum, like I already mentioned in the database, the one rice quantity is 1 kg and oil quantity is 1 liter. So after reaching the 1 liter in flow sensor, the solenoid will automatically will be stopped and the dispense will be stopped. Like this way, our project will work. Thank you.
I am Sujay. My teammates are Mr. Varun, Sajjan Kumar. Our project is design of SPI bus. This is a block diagram of SPI bus. It mainly consists of 4 wires. One is serial clock, MISO, MOSI, and chip select. The master will send the data from master to slave through master out, slave in, and after receiving the data, it will send the acknowledgement through MISO. And then the chip select is used for whenever we have 2 to 3 slaves. The chip select is used. Here we are using we have done optimization by using Genus tool, and floor planning and placement by using Innovas tool. This is the results of floor planning and placement.
I'm Jayant. These are my teammates Chetan Gowda, Anish, Lakshmikant. Our project is real-time epileptic seizure attack detection and alert system. Epilepsy is a neurological disorder which causes the brain not to work properly. There are 2 types of neurons that are present in the brain, aneuron and neuron. Aneuron increases the amount of electrical signals passing through the brain. Neuron suppresses these signals. Both should be efficiently working so that the brain works normally. Our aim is to detect the epilepsy by using a low-cost device. We have made this low-cost device just in 7,000. The same device is being implemented in foreign countries which cost more than 1 lakh with ambulance services and medical services. This is the PCB board that we have designed. This is the GSM module which sends the signal to the guardian of the patient if the patient falls or has any attack. This is the accelerometer, which is ADXL 330. It is also called as a microelectrical mechanical sensor, which senses the body movement of the patient. If the patient falls or if is having any attack or seizure attack, this accelerometer detects the attack and sends the signals to the PCB board. And first the buzzer would ring, seeing that the patient has been fallen. The patient needs to press the button so that he is normal. The water pump sprays the water if he falls. The same is been sent. The message will be sent to the guardian or the hospital regard that he has fallen. This is the IoT platform ThinkSpeak, which gives the data about the seizure attack detection and latitude, longitude, and the seizure attacks. How frequently the person has seizure attacks. Thank you.
Hello, I am Devakar. My teammates are Deepak, Sunil, Rajana. My project is automatic weight segregation. Automatic weight segregation, it will separating three different of waste: plastic, dry, wet and metal. And it is a pickup conveyor, it is a filtering process, and it is a carry conveyor which separate the dry and wet waste and metal waste. Here we separating small particles of metal in filtering process. Here we place it electromagnetic in down way. It captures the small particles of metal pieces in the electromagnetic. After that, after the processing, it will be dry and wet will be separated. Here we showing pickup conveyor, how pickup conveyor is working. Here we are placing two sensor, proximity sensor and the proximity sensor and metal sensor.
Mates are Nandish and Rashmiel. So this is hybrid inverter which we have designed. So this is hybrid inverter which we have designed. So we can see battery, a digital voltmeter, hybrid inverter, step up transformer, load with bulb, okay, 12 volt solar panel and main power supply. Okay, so I will go with the working of the project. So in normal inverters, what will be done is, in normal inverters the battery will be charging from the normal kV power, so that is an unnecessary cost. So to avoid that, we are going for an hybrid inverter. So what the hybrid inverter does is, during daytime this solar panel generates electricity which is used to charge the battery and also give the supply to the loads. There is no use of main power supply. Okay. So during night time the solar energy will be zero. The battery will be charged at the night time. From morning till evening the battery will be charged. So now it's showing 10.9 volt. So during night time, once the main power supply goes off, as we can see, the battery, the hybrid inverter shifted the power supply from main power supply to the battery. So we can see 9.5 volt. So there is no charging takes place, no charging from main power supply. 9.5 volts. The 12 volt DC power supply is converted to 220 volt AC supply to the step up transformer. Now the bulb is glowing. The battery status is 9.9 volt. So during daytime, so I will switch on the main power supply. As you can see, after coming the main power supply is turned on, the battery status shows at 10 volt. So this means that it is charging through AC mains, not solar. Solar takes time. To charge this battery, we need 4 to 5 hours to charge this battery. So from whole day, the battery will be charged fully, and to the night time it will give 5 to 6 hours of backup for bulb and fan. So this is a small scale setup. We can go for larger scale setup like 1 kilowatt, 2 kilowatt, 3 kilowatt, up to 5 kilowatt based on our requirements. We can set up the same project in our home. So main advantage of using hybrid inverter is it will reduce the cost. It will minimize the use of main power supply from outstation and maximize the use of solar energy. Thank you.
My name is Akash. My teammates are Anusha, Ananya, and Sagar Vadagere. My topic name is automatic wall painting robot. Automatic wall painting robot. We have used two ultrasonic sensor for the front facing of the wall and side facing of the wall, and we have used a robot arm with 3 DOF servo motors, and we have used tube like structure where the paint is kept, and it is used for the dumping of the paint. The method is where the wall is sensed at 20 centimeter and it will turn left, and the side wall is calculated by the side ultrasonic sensor where it starts the painting process. Starting it will dump the paint and it will paint the wall, and again it will move for about 5 to 10 centimeter, and again the process continues till the ultrasonic sensor is met with blank value. Example for 60 centimeter to 70 centimeter. Thank you.